This video is going to look at a second theory of acids and bases called Bronsted-Lowry acid-base theory. It's on the regions going to be called the alternate theory of acids and bases, so if you could add that into your note packet, or the other theory of acids and bases. But now they typically do not refer to it as Bronsted-Lowry. It's alternate or the other. And it has to do with the idea that acids are H plus or proton donors and bases are H plus acceptors. And because we love acronyms, I want you to write this down on your paper, BAAD. For B, you're going to write bases, A, accept, A is acids, and D is donors. So I know it's not spelled right, bad is B-A-D, but it's an acronym at least to help you remember. Bases accept, acids donate. And in this case, we're dealing with protons in both cases. So bases accept H's, acids donate H's. I know in the last video we talked about Arrhenius theory, and bases were hydroxide or produce hydroxide ions in solution. So here sometimes people want to pick the bases accept hydroxides. They're not accepting hydroxides. This is all about H's. So when you look at an equation, what we're going to do is we want to match up what we call our conjugate pairs, or things that look exactly like something else on the other side of the equation. There's just a difference in the number of hydrogens. So if we look over here, this is going to match up on the other side of the equation with this. The only difference is this has one hydrogen, this has none. And water will match up with H3O. The only difference is the number of hydrogens. Hydronium on the right has 3, and over here we have 2. So when we're looking at trying to identify a conjugate acid-base pair, you're going to look on the opposite side of the equation for something that has a different amount of hydrogens, just one, like it could have one more or one less. Of that pair, meaning of H2O and H3O, the one that has more hydrogens is the acid. The one that has less hydrogens is the base. So H3O would be your acid, and H2O its conjugate base. And the same thing, you have HC2H3O2. This has an extra H, so this is your acid. And over here is going to be its conjugate base. So we're identifying what we call conjugate pairs, things that are different from one side of the arrow just by one H. So here's another example. We have nitric acid and water. On each side of the arrow, there will be one acid and one base on each side. So acid, base, acid, base. We look at water and hydronium. The only difference is the amount of H's. Hydronium has one more H, so since it's an acid, it will donate that H to the water, H2O, which could accept the H. We have HNO3 and NO3. The one with more H's is the HNO3. That's the acid because it's going to donate. Acids donate. Remember, bad. Bases accept, acids donate. It has an extra H that it can donate. So in this question, they give you an equation, and they say according to the alternate acid-base theory. That's how we know we're not talking about Arrhenius. The alternate is the one that we just described. You have to figure out what your pairs are and figure out which ones are the acids. So we would have HNO3, just like we just looked at, is going to go with the NO2. The NO3, I'm lying, sorry. Let's fix that. We have HNO3, we'll go with NO3. So this is a pair. The H, the one with more H's, is the acids because acids donate. And we have H2O and H3O. This has more H's, so it's the acid. So our answer would be choice 4, D. So let's do one more example. We have HCl plus water, or hydrochloric acid plus water, gives you hydronium and chloride ion. We're going to make our pairs. HCl will go with Cl. This will be the acid. This will be the base, the acid because it has an extra H, so it can donate. Here's H2O and H3O. This is a conjugate pair. This has more H's, so it's the acid. And this is the base. What they're going to ask you is which one are proton donors? Well, you have to know that acids donate, so if I'm looking for the proton donors, it would be HCl and H3O. If I said which one are proton acceptors, it would be Cl minus and H2O. Sometimes they ask for the forward reaction. If they're asking for which one is the proton donor for the forward reaction, well, acids donate, so I'd be looking at the left-hand side. I'm talking about forward, so it would be HCl. If I said for the reverse reaction, I would be looking at my products. So H3O plus would be the proton donor. So they could ask about forward and reverse reactions too.